Cool. Your sphingolipids. Your sphingolipids, and I actually have a slide for them, which makes me happy, because I honestly don't know too much about sphingolipids, except that you find them in nervous tissue. So your sphingolipids, contain sphingosine, which looks like this, big long chain. Notice it doesn't look so big and long down here, but that's because this is repeated over and over 6 times. But they contain sphingosine, a phosphate, a fatty acid, and an alcohol. And here's an example. This is sphingomyelin. Where do you find sphingomyelin? Yeah, your myelin sheaths around your nervous tissue. Cool, that's all I really wanted to say about them. So let's talk about your isoprenoids here for just a minute. Your isoprenoids. Good times. Examples would be called terpenes. So terpenes are made from this, what we call isoprene unit. And if you kind of look, you can kind of see how these kind of form and stuff like that. But the general backbone forms from a little 5-carbon chain here. Notice it's 4 carbons with one of the middle carbons having a methyl group coming off of it. That's your basic carbon skeleton for these terpenes. And you can kind of see, like, if this double bond is used to, say, make a bond right here, which causes this one to shift over right here, which causes this one to move down the chain, say, right here, and this one to go further, say, right there, and this one to go bond to the next one, so on and so forth. So the isoprene unit had a couple of double bonds. Now your overall product to be a terpene, it doesn't necessarily have to have any double bonds. They usually, still have a few or something like that. But you might see some of these double bonds hydrated, becoming alcohols and things of this sort as well. So you might see them cyclizing and forming rings. But the key is, you might just be forced to identify looking at a structure and figure out, well, how many terpenes, how many isoprenes were in that terpene? And so in something like this, you'd be like, there, 1, 2, 3, 4 with a methyl coming off the middle, there's one. 1, 2, 3, 4 with a methyl coming off the middle, there's one. 1, 2, 3, 4 with a methyl coming off the middle, there's another. And so maybe you got to count how many isoprenes a certain terpene had or something like that. I don't know. So if you're in an OChem class taught by Dr. Leffler, he might actually put a big giant molecule on there and have you circle them all. But you're not in his OChem class, so you lucked out. Probably won't have to do that. I can't guarantee it, but probably not. I put some of the most common on there: scaline, beta-carotene, vitamin A, vitamin E, vitamin K. So notice those are all your fat-soluble vitamins, which like to stick around in you for quite a while in your fats. So you get your fat-soluble vitamins, your water-soluble vitamins. So what happens if you take too much of a water-soluble vitamin? Yeah, you'll get rid of it, as you pointed out. But if you take too much of fat-soluble vitamin, it might take you a little longer to get rid of it because it'll get stored in your adipose tissue. So notice vitamin E is really good for you, right? Well, it is if you don't take too much. So if you take too much, what's really good for you becomes a poison, but that's kind of true about everything, right? Except ice cream, but everything else. Steroids. In fact, I don't really need to write this up here. So steroids, what are steroids? So they're hormones. So we often think of them as, often cases, testosterone, progesterone, estrogen, as your sex-linked hormones. They don't necessarily have to be sex-linked. But the big key, the thing I have in common is they all are derived from cholesterol. If you look in the text box on your handout there, cholesterol's right there. It's got those 4 characteristic rings. And all of your steroids look remarkably similar to cholesterol because they all come from cholesterol. So note also, though, that vitamin D and bile also come from cholesterol. What's bile for? Breaking down fats. Where does it come from? from your liver, gets passed through the gallbladder, then into your gut, if you will, but used to break down fats. So it's also derived from cholesterol.